Hello, math application students, and welcome to your online lesson. Today we'll be talking about something known as the converse of the Pythagorean theorem. So we're going to build on what we know about our review on the Pythagorean theorem from last lesson, and now we're going to use the Pythagorean theorem to identify right triangles. So to figure out, is it actually a right triangle or is it some other kind of triangle? We will know we are successful when we can efficiently identify triangles as right using the Pythagorean theorem. So when can we use the Pythagorean theorem? This was a question we asked on our previous lesson, and the answer is we can use it when we have a right triangle, and then we can use it to find missing sides of that triangle. And again, that Pythagorean theorem is a squared plus b squared equals c squared, where a and b are our legs, or the two sides that form the right angle here. And then the hypotenuse is the one opposite of the right angle, or across from it. It's also the longest side. Again, if you have a right triangle, you can, we know this statement will be true whenever we have a right triangle, and then we can use it to find missing sides. But the question arises, how do we know if a triangle is a right triangle? Well, usually it's labeled as such, often using the little square to show that there's a right angle. And if it's a triangle and it has a right angle, it's a right triangle. But what if it's not labeled? What if it looks like it might be a right triangle, like something in the real world might, but you're not sure if it actually is a right triangle or just something that appears close to a right triangle? Well, again, if we know that the Pythagorean theorem only works on right triangles, we can just check using the Pythagorean theorem to see if we get a true statement. Again, using the Pythagorean theorem with the values from our triangle, our potentially right triangle. Now, just looking at this one, it doesn't necessarily look like it's a right angle, but a lot of times things aren't drawn to scale, and because of the way things are oriented or tilted, they may appear it. If there was going to be a right angle on this, it would have to be across from the hypotenuse, and since the hypotenuse would have to be the biggest side, 6 centimeters would have to be our hypotenuse, which means our right triangle, if it exists, would have a right angle where the 4 and the 5 intersect each other. So the question is this a right triangle? Well, let's start by writing our formula down. We're going to have a squared plus b squared equals c squared. And as we said, the longest side always has to be our hypotenuse. And so we're going to replace the c with our hypotenuse length of 6. So we'd have 6 squared replacing the c squared, and then our other two sides would have to be our legs. They're the shorter two sides, so we'd have 4 squared plus 5 squared. As we put this all together, we're going to have 16 plus 25, though you could certainly do this left side just straight into a calculator in one step, and that's going to equal 36. Now when I add up 16 plus 25, I end up with 41. Now 41 is close to 36, but it does not actually equal 36. So is this a right triangle? And the answer is no, it's not a right triangle. Now you might be asking a follow-up question, which is, well, then what kind of triangle is it? Well, if it's not a right triangle, it could either be an obtuse triangle or an acute triangle. An acute triangle is a triangle that has all acute angles, and an obtuse triangle is a triangle that instead of having a right angle, it has one angle that is greater than 90 or obtuse. And again, acute angles are ones that are less than 90. So looking at this particular triangle, we had our final statement that said 36 and 41, which were not equal. And 36, again, was our hypotenuse squared. Well, I'm going to draw a little right triangle here. And on this right triangle, if I were to make the hypotenuse a little bit smaller so that I sort of shrink it down, and I'm going to like kind of draw it right here. Well, now this other side right here would have to tilt in to complete the triangle. And what we've done is we've made that 90-degree angle actually smaller than it was initially. And so if it's no longer 90 and it's now smaller, that would be acute. And so an acute triangle is going to be one where the hypotenuse is smaller, or even the square of the hypotenuse is smaller than the sum of the squared legs, which is what we had in this case. The hypotenuse squared was only 36, whereas the sum of the legs squared were or 41. Now, if it was an obtuse triangle, again, if we look back at that original example here and draw a right triangle. Now what happens if we extend our hypotenuse and make that hypotenuse just a little bit bigger? Well, that would mean that this side right here would have to tilt the other way, more or less. And it would open up this 90-degree angle and make it a little bit bigger, so it'd be obtuse. So if your hypotenuse is too big, then you've got an obtuse triangle. And if your hypotenuse is too small, you would have an acute triangle. Let's look at a couple other examples. So again, we're going to use the Pythagorean theorem to determine if this is a right triangle. This one we've got some bigger numbers, so we may want a calculator to help us out with it. But to start off with, let's write our formula down. So we've got a squared plus b squared equaling c squared. Again, our c is always going to be the biggest one. We don't know if it's a hypotenuse yet because only right triangles have a hypotenuse. But if it was a right triangle, we know that the hypotenuse would have to be the 130 because it's the biggest length. The other two would be the legs. So we have 50 squared plus 120 squared. And of course, the order doesn't matter on the legs. So we could have 120 squared plus 50 squared as well. I'm going to go reach for a calculator now at this point so that we can check these values. And if I take 50 squared plus 120 squared, I get 16,900. So 16,900 is the value of our left side of the equation. And the right side, the one that had the hypotenuse, is 130 squared, 130 squared, which gives us the exact same value. So is this a right triangle? Yes, it's a right triangle. And again, we know that because the left side of the equation, which was 16,900, is equal to the right side of the equation, meaning that this equation was true. A squared plus b squared did equal c squared. And again, that only works if we have a right triangle. All right, one last example here. We have some decimals. Now, my initial gut is whenever I see decimals, sometimes that can imply rounding. And if we have rounded values, then we're probably not going to get something exact. But we can reserve judgment until we actually do the math and see what happens here. Once again, we need to find what our biggest side is currently. Well, the biggest one currently is the 2.23. So that would be our potential hypotenuse. So a squared plus b squared equals c squared. So I'm going to plug in the 2.23 squared on the right side there, replacing our c, our potential hypotenuse. And then my a, I'm going to make 1.73 squared. And my b, I'm going to make 1.41 squared. All right, once again, I'll use the calculator to help me out to see what the value of the left and the right sides are. So starting with our left side, we've got 1.73 squared plus 1.41 squared. And that gives us 4.981. 4.981. Now let's try the right side, which is just 2.23 squared. 2.23 squared. And boy, they sure are close, but they are not the same. Sorry. We've got 4.9729. So are these, do these sides form a right triangle? And the answer is no. And we know that it's not a right triangle because the left side of the equation does not equal the right side. Even though they're very close, they wouldn't even round to be the exact same value, at least at this point. So then the sort of bonus question would be, is this an acute triangle or is this an obtuse triangle? And to remember, once again, the hypotenuse part, if the hypotenuse were to grow, if we were to extend out this line here, that would make this angle here open up more and go beyond 90 degrees, which would make it obtuse. So if your hypotenuse part is bigger than your leg part, we know it's obtuse. And the other way around, if your hypotenuse part is smaller, then that would mean that our angle has sort of shrunk down being less than 90 degrees. Well, in this case, which one's bigger? The answer is this left part here, because it's 4.98, whereas the other one is 4.97. Well, those were the legs, and if the legs are bigger, that means the hypotenuse portion, or potentially hypotenuse portion, is a little bit smaller, so this would be an acute triangle. So no, it's not a right triangle, it is acute. All right, and that's going to finish up our lesson for today. Until next time.